Hello students, let us discuss about the coordination chemistry, the second part. We have discussed this in another video, the first part. So coordination chemistry is about the coordination complexes. So one coordination complex picture you can see here. So in the previous lecture, I have discussed about the discovery of coordination compounds discovered by Werner, Sulfate Werner, for what he got the Nobel Prize. And then the postulates of the theory were discussed. Mainly the primary valency, secondary valency, ionizable ions, non-ionizable ions, all these things. And so let us start our today's lecture on the IUPAC nomenclature for coordination compounds. Here you can see the common one structure of coordination compounds. Here I want to say that the coordination entity will be given within the square bracket, where there will be a metal in the center which will be called as central metal ion or atom. There will be ligands surrounding the metal ion who will make a coordinate bond with the metals, and these will be called as ligands. So ligands can also exist outside the coordination sphere or coordination entity. Those will have ionic interaction with the metal center, and the ligands inside the coordination entity, they will have covalent coordinate bond with the metal center. So the nomenclature of coordination compounds are very important one. So let us discuss the point wise. There are some points are given to name a coordination compound. So the first point tells us that the cation is named first in both positively and negatively charged coordination entities. Now you already understood what is coordination entity. Here let us understand this point with two examples. First example of this one is a coordination complex. Second example is this one. This is also another coordination complex. But in this case, you see that here the coordination entity that is given within the square bracket is actually a anion, because outside there are three positive ions, potassium ions. Therefore, this part, the coordination entity part, is a anion. But in this example, you see there are three chloride ions outside the coordination sphere. That's why the coordination entity will be a positively charged ion. Why like this? Because to balance the ions, balance the charge, because finally the complex will be neutral. Okay, to balance the charges, if outside it is a positive ions are there, the coordination entity will be negative, and if outside and negative ions are there, the coordination entity will have positive charge, and that will be exactly balanced with it, because here three chloride is having one minus one charge, so they will be three chloride minus and is there, three minus, and it will be then 3 plus. Now you see the name of this is potassium trisoxalato aluminate, and the name of this compound is triamine triaqua chromium chloride. Okay, now you can see what this point describes, that cation is named first. So here the cation part is K plus. So the cation will be named first, that potassium will come first. Then the coordination entity will be named. Okay. And for this example, first cation part is this coordination entity. So that is named first, and the chloride is going to the last. Okay. So that is the explanation of this point. I hope you understood this one. Then let us go to the second point, that the ligands are named in an alphabetical order before the name of the central atom or ion. Okay, so here you see the example where two different ligands are there in this coordination entity. So this is ammonia is actually abbreviated as amine, and water is abbreviated as aqua. Now you see amine starts with A, aqua also starts with A. Both alphabet is same. So then which ligand we have to write first when we are writing the IUPAC name? If first letter is same, then we have to move to the second letter. So in this case of amine, there is M, second position, and aqua there is Q. So amine will come first. M comes before Q in alphabetically. So amine will come first and aqua will go next. Now you see when there is 3 number of amines and 3 aqua, so we'll write tri. So this tri, di or bis which we write to show the number of ligands, that will be actually not considered when alphabetical order is followed for naming a coordination compound. Okay, so the alphabet of tri, di, this will not consider. We will consider the alphabet of the ligand only. Okay, so I have you have understood this point also. Next, the names of the anionic ligands end in O. Those of neutral and cationic ligands are the same. So what this point says? You see here this amine and aqua. These molecules are neutral. These ligands are neutral. There is no charge. Therefore, it will be called as amine only and aqua only. Okay, but in this example, you see there is oxalate ligand. Oxalate is this ligand, okay? Oxalate is having 2 anions, 2 charges, okay? It is a dianionic ligand. So when there is an anionic ligand, that O has to be added in the end. So it is oxalate, will be called as oxalato, okay? But in case of neutral ligand, you see triamine, triaqua. There is no O at the end. So that is this point explains. Let us go to the next point. We have to give the prefix like di, ti, or sometimes it is also given as bis, tris or tetrakis, depending on the number of each type of ligand. Right? But when we will use di or tri or tetra, and when we will use bis, tris or tetrakis, which prefixes has to be used, that we should understand, because di means also 2, bis means also 2, tri means 3, tris means 3, tetra means 4, tetrakis means also 4, and which one will be used. Let us understand with some examples. If this example you can see, so the name of this compound will be given as dichlorido bis triphenyl phosphine nickel 2. So chloride is here, number is 2 and it is an anionic ligand. So there will be O, addition of O, chlorido, and there is 2, so we can write di. But you see the another ligand, this ligand is called triphenyl phosphine ligand. Now triphenyl phosphine ligand itself having a tri inside its name. So, and two number of ligands are available. So then outside we cannot write again di. Okay. So when the ligand itself is having di, tri, bis, di, tetra, this type of wordings, then when we are giving the IUPAC name, we will use bis, tris or tetrakis instead of di, tri or tetra. That's why in this case it is used dichloro but bis triphenyl phosphine, then nickel 2. Okay, so some other situations also occur when we use the bis tris tetrakis. When you see this ligand is 2 ligands are there, which is methylamine. The methylamine ligand, let's say 2 methylamine ligands are there. So we will not use dimethylamine. We will use bis-methylamine. Why? Because there is already another ligand in this name, dimethylamine. This is the ligand. So you can see the difference between these two. These are not same ligands, right? These are not same ligands. They are different. You can see their formula. Their formula is totally different. You properly check it. So already as dimethylamine, one ligand is available, we cannot write here again dimethylamine because it will confuse you that if methylamine, two numbers of methylamine is present or one dimethylamine ligand is present in the as a ligand. Okay, so to avoid the confusion, here also bis-methylamine will be used. Another case will occur when you see the iodide ligand, three iodide ligands are there. Then also we cannot write triiodide. We have to write trisiodide. Why? Because triiodide already another anion is there, which is I3 minus. So I3 minus ligand ions is also there, which is called triiodide ligand. So it will be confusing if we write triiodide. It is triiodide ion or three iodide ligands are there. So that will be confusing. So if three iodide ligands are there, it will be written as tris iodide. But when only one triiodide ligand is there, it can be written as triiodide. Okay, so in these situations, we have to use bis-tris or tetrakis. Similarly, for phosphate, we have to write bisphosphate instead of diphosphate because diphosphate already another anion is there. And then similarly for oxalato, this anion I have shown in the previous slide. So oxalato will be also written as tris oxalato. Why? Because there is, what is the confusion here? Because the oxalate IUPAC name is ethane diet. So there is also di inside its name, actual IUPAC name. Because here oxalato we can write and some can also write ethane diet. So if we write ethane diet, then outside we have to write, if three number is there, tris. We cannot write tri. Okay, so these are the things when it should be remembered when as a prefix di, tri or tetra is used, and when bis, tris and tetrak is used. Okay, to avoid any kind of confusion with its original name. Okay, this is the purpose here. So I hope you understood this point. And then another point, 5, oxidation state of the metal in cation, anion or neutral coordination entity is indicated by Roman numerical in parentheses. So what is this? You see, when you are, this is as an example, you see you are writing potassium tris oxalate aluminate 3. So you can see in bracket there is a Roman letter, numbers are there. So this is what? This is actually the oxidation state of the metal ion inside. Okay, if the metal ion having oxidation state +3 or like, that's why it is given 3. Okay, so that is the way to write it. And the next point says that if the complex ion is a cation, the metal is named same as the element. For example, okay, you see, if you have the coordination entity as anion, like we know this coordinate here, the coordination entity is the anion, that case we have to add it with the name of the cation, with the metal. So the aluminium is there, so we have to write here aluminate, not aluminium, because it is a part of a anion. But when the coordination entity is neutral or positive, like in these two cases, first one is neutral, okay, there is no charge on the coordination entity. That case we will keep the name same as it is name of the metal ion. So here we can see that this is cobalt, triamine trichlorido cobalt 3. So it is not cobaltate, it is only cobalt because it is neutral. And in this case, this coordination entity is cation. We have already seen this one before. So cation case also it will be remain same name like triamine triaqua chromium chloride, chromium 3. So it is not chromate. So this is the things in this point, it is telling. Okay, so all these points are very important to keep in mind so that you can correctly write the nomenclature of the coordination compounds. Here another thing to mention, sometimes we have to use the Latin names of the metals. When we are adding it, when it is a part of a anion, the coordination entity, we have to add it with the metal ion. But then for these metals, we generally use the Latin name. So iron will be called as ferrite, copper, cuprate, tin, stannate, silver, argentate, lead, plummet, gold, orate. For example, you can see in these two examples where the central metal atom or ion is iron. So here iron is a part of a negative coordination sphere. That's why it will be added and it will be not iron, it will be called as ferrite. But in the next example where the coordination entity is a neutral, so here it will be called as iron only. So no it, so it will be used normal name iron 0. Okay, so I hope you understood till now here what are the rules to write a perfect IUPAC name of a coordination compound. Here list of the ligands are given. So ligands can be anionic, neutral or cationic. So negative anions ligands are given here. All these examples and their name, what is written. Okay, you have to remember this one, and here all O are added because they are anions. And there are very few positive ligands like nitrosonium, nitronium, hydrazinium, and there are neutral ligands are present. So you have to remember the names of the ligands to write the IUPAC name. And there are few and neutral ligands where their names, different names are used. Like for water, it is aqua, for ammonia, amine, for nitrosyl, carbonyl. So these words will be used when we are writing the IUPAC name. So as an exercise, you should follow some of the names are given from where try to write the formulas, and it can be also the formulas can be given and you may have to try to write the IUPAC names. Okay. So here we finish the IUPAC namings of our coordination compounds. Next video we are going to start isomerism in the coordination compounds.